Students, and welcome to the fourth virtual class. Today's topic is conversion between liquid and gas. So when the liquid gets converted into the gas on heating at a constant temperature, that process is known as the vaporization or boiling, and the temperature at which this process happens, that constant temperature is called its boiling point. For example, water at 100 degrees Celsius converted into steam again at 100 degrees Celsius with continuous supply of heat. Now both the temperature are same again here, and the reason is going to remain the same. That is, the heat which we are supplying, that is utilized in doing work against force of attraction and to increase space between the molecules. Now the reverse of this case, that is gaseous to the liquid state, by rejection of heat again at the constant temperature, then this whole process is known as condensation, whereas the temperature at which this happens, that temperature is known as condensation point. From these two processes, we have the few conclusions here. That is, first one, for a substance, boiling point and condensation point are same. The amount of heat absorbed or rejected during change is same for the same mass of the substance only. All liquids expands on heating except for water, because water has some exceptional behavior, that is known as its anomalous behavior of water. Fourth point, boiling point increases with increase in pressure. Therefore, it is difficult to cook vegetables at mountains where pressure is low, but it is easy to cook in the pressure cookers. With the addition of impurities, the boiling point is going to increases. There is one more term in which the same process is happening, that is liquid gets converted into the gaseous state, and that term is known as evaporation. But it is not same to as the boiling case. It is different from the boiling, and the difference is, in order to reach the boiling state, we will first have the evaporation state. That is, evaporation occurs at every temperature before boiling point reaches there. Rest of the differences you can see in the textbook page, which I'll post at the end of this video. Next is the rate of evaporation. Now the rate of evaporation depends upon few factors here. The first one is temperature of the liquid. If we will increase the temperature of the liquid, the rate of evaporation is going to increases. For example, a wet cloth dries up on a hot day much faster than on a cold day. Second point, area of exposed surface. Greater is the exposed area, greater is the rate of evaporation. That's why a cloth dries up faster if it is spread out than if it is folded up. Third point, nature of the liquid. There are few liquids known as the volatile liquids whose are having low boiling point. For example, alcohol, ether, etc. evaporates much faster than the water. Why they evaporate much faster? Because they have the low boiling point. This is the reason the volatile liquids are always stored in a tightly closed bottles. Fourth point, flow of air above the liquid. Greater is the air blown, greater is the rate of evaporation. Fifth point, presence of moisture or humidity. Lesser is the moisture, greater is the rate. That's why wet clothes dry faster in summer than in the rainy season. Because why it happens? Because there are already moisture or water content in the atmosphere. That's why the rate of evaporation decreases. If there is no moisture, it means the space is there for the other water droplets to go into the atmosphere. That's why if greater is the moisture, lesser is the rate of evaporation. On the basis of these factors, we have many applications in our day-to-day life. For example, water gets cooled in earthen pot. During summer, we always keep the water in the earthen pot. Why? So that when we have the evaporation from the earthen pot, because there are very fine pores in the pot through which the water gets evaporated, and to get evaporated, the water takes heat from the inner water, and this way the inner water temperature decreases. Doctors advise to put the stripes of wet cloth on forehead when we have fever. Why? We are keeping this wet cloth stripe on our forehead when we are in fever, so that the water of the wet cloth gets evaporated by taking the heat from the body, and this way the body temperature decreases. We often pour tea in a saucer to cool it down. Here we are increases the exposed area, and greater is the exposed area, greater is the rate of evaporation. Our body maintains its temperature always 37 degrees Celsius even if outside temperature is very high. Why? Because body is going to sweep out the sweat if the outer temperature is high, and to sweep out the sweat is going to take the heat from the body, and that's why the body temperature is going to be maintained. The most important point here is the evaporation always produces cooling effect. So if we will have a volatile liquid on our palm, it will get evaporated very easily because its boiling point is very less. So if it will evaporate, it means to get evaporation, it will take the temperature or the heat from the palm. So that's why the palm temperature is going to be decreased and we feel a little cooling effect on our palm. Last conversion, that is from solid to gas or gas to solid directly without the liquid state. So when the process in which the solid gets converted into gas directly by absorption of heat, that process is known as sublimation, and the reverse of this by rejection of heat, that process is known as solidification or deposition. For example, when ammonium chloride, iodine, camphor, naphthalene and solid carbon dioxide are heated, they gets converted into their vapor states. When carbon dioxide gas cooled, then it gets converted into solid carbon dioxide, which is known as dry ice. Sometimes sublimation also takes place without even heating. For example, naphthalene balls, which we use to protect woolen clothes from insects, directly changes into vapor, and with the time they become very small in size. Why? Because they have very low boiling point. Now why they have the direct conversion from solid to gas or gas to solid? Because in some solid the intermolecular forces of attraction are so weak that on heating these molecules acquire sufficient kinetic energy to overcome the forces of attraction and they become free to move. Thus their intermolecular spacing becomes very large and they gets converted into the vapor state. Now we have finished the chapter. I'm posting the pages of the textbook for your reference. Thank you so much.